Greetings. In this video, we are going to be talking about your programming assignment for your class in data structures and algorithms. This is actually a three-part assignment. You'll have to write the program over 3 times. The user interface is going to remain the same and the functionality is going to remain the same. What's going to differ in the 3 assignments is what's going to be happening underneath the hood, as we say. You're going to be changing some of the internal structures of your program, but to somebody watching the program, it's going to look exactly the same. So what we're going to be implementing here is a very simple database application. Some of you may have already had a class in database, and others of you may not. That is okay. Simple database application. And it might be something that's used at the university, something that we're going to be keeping track of students. And it's only going to be single file. We're just keeping track of one set of attributes. And in fact, what's going on here is we're going to be keeping track of students. We're going to track students, and the attributes here we're just going to assume that every student has a first name. We're going to assume that every student has a last name. And we're going to assume that every student has an ID number. And for purposes of this assignment, we're going to assume that the ID number is 5 characters. Likewise, we're going to make a couple of other simplifying assumptions here when it comes to writing this in Java, and I believe everyone's going to be writing this in Java. We're going to assume that all of these are string. And that's going to make your life a whole lot easier. So in this example, as we continue, we're going to be using 3 sample students here that we're going to input. So we're going to have, the first, and we're going to have the last, and we're going to have the ID. And the first student that we're going to have is named Gabe Ninda. And Gabe will have an ID, we'll give it 90124. And then our second student is going to be Anton Limbo. And Anton will have a student number that looks like this. And our third student that we will have will be Anna Shapepi. And Anna will have an ID number that looks like this. Now, what we're going to assume is that we have this database file that we're setting up, and we're going to insert Gabe first, and then we will insert Anton second. We will insert Anna third. A couple of things to say about database files. We all know that when it comes to database files, one of these attributes here, either first, last, or ID, has to act as the key. And what it means to be the key is it means that the values here have to be unique. They can't be repeated. You can't have any students in here that have the same ID number. Now, you may have students that have exactly the same name. There could be 2 people named Gabe Ninda, but they would have to have different ID numbers. So I'm going to designate over here that the ID is the key for the database file. And again, I think that is known to all of you, the idea that keys have to be unique. The other thing that we're going to do as I am explaining this assignment to you is we're going to assume that the students got inserted in this order right here. So we inserted Gabe first, then Anton, then Anna. Now, when it comes to database functionality, there are a couple of things that we like to have here. First of all, we'd like to be able to search by the ID number. And we know that what that means, the program should come up and it should say, please enter an ID number, and we might enter 80003, and it should come back and it would print out Anton Limbo and give the ID number. If we come back and we ask for an ID number, say 70000, it should come back and it should respond to us, there's no such ID number. So that should be pretty straightforward. We should be able to list by attribute. And what that means is I should be able to say to the system, please list by the first name. Now I want to add another feature. I want to say that this can either be in order or it could actually be in reverse order. So what that means, and I'm running out of a little bit of room here, let me move this over and leave that over there. Suppose I should be able to say to the thing, I should be able to say to the system, please list by first name ascending. And if I do that, okay, we can see over here, if I'm going to do it by the first name ascending, we can see that if I look at these first names, alphabetically the first name would be Anna. So the system would come back and it would say something like the following. It would say Anna Shapepi, and I made a mistake here. Anna Shapepi has an ID of 8,500. And then it would come over here and it would say Anton Limbo. And Mr. Limbo has an ID of 80,003. 80,003. And then it would come over here and it would say Gabe Linda. And that would be 90124. Okay, so that would be an example of listing by the first name ascending, but I should be able to do something like the following. I could say, please list by last name. Let's find this. I could say last name ascending. And if I were going to do that last name ascending, the first one to come out would be Anton. And then after Anton would be Gabe. And then would come Anna. Okay, so that is another option there. I might say list by ID descending. And in that situation, it would come back and it would say and let's see, then it would have Anna. And then finally Anton. Okay, so we note that no matter how we print out the information, we're printing out all the information, the first name, the last name, and the ID number. What's different is just the order that it's coming out in. We've got 3 different attributes. We can print them out in ascending or descending order. So that would be a total of 6 different ways of outputting this information. Okay, let's start talking about how we're going to put this program together. So recall we have these 3 students right here that we're going to insert into our database, and we're going to insert them in this order. So this is number 1, number 2, number 3. And the first first class that we need to define is what's called a database record. So we have public class database rec. And it's made up of 3 fields here, okay? All of them strings, so it's a pretty simple object. There's a string called fname, a string called lname. There is a string called ID. I'm not going to write all of the code in here. I think that you folks can figure this out. But we certainly need to have constructors. We might need to write a toString operator. In fact, I think that would probably be a good idea. And I'll leave it to you to determine if there should be any other methods contained within this class. But again, we can imagine how this thing is going to work. If we had already defined it, if I came over here and I said, okay, I want to declare an instance of a database record. So I say database record db1 is equal to, and now I'm invoking the constructor. I say new database record, and I'm passing it 3 strings, the first name, the last name, and the ID number. And we can imagine that what that does in memory is we create this variable called db1, which is actually a reference to this object that we've defined over here, a database record. And this is what it would look like. I'm going to repeat this later on, but I'll say it here just to get you all thinking about it this way. There is a tendency for people to say, well, what I really want to do is I want to create 3 separate arrays of strings. And I'll have one array for the first name and one array for the last name, and I'll have one array for the ID number. And I'm going to say that that's not what we want to do. We are going to define an array very shortly, but we want it to be an array of these objects right over here. Okay? Okay, to continue, our ultimate goal here, we're going to be defining a very big class. The very big class we're going to be defining here is called a database. So there's going to be a public class database, and a couple of things that we're going to talk about here. One of the things that a database contains is it contains an array of database records. Now remember, database records are what we defined before. So I'm going to come over here and I'm going to say, well, we should make it private. So we're going to have private database record, and we'll call it, and we'll make it an array. data. Okay, and I'm going to come over here and I'm going to say private int. I'm going to call it next DB record. Call it next DB rec. Okay, now one of the things you'll have to do, you have to fill in the code over here. But in your constructor is you'll have to allocate the memory for this. We may assume that if you want to play it safe, you can dimension this to be 100. I leave it up to individual folks to decide how big to make this. For the test data that I've given you, I believe there are about 60 or 70 records. So to dimension this to 100 would be fine. And basically, there are going to be other things that we're going to be adding to this class, but we're just going to be discussing how this works right now. So let's imagine that we've got this thing set up. So here's a variable over here, and this is next DB record. And over here, I've got this array data, and this is some big array. But remember, this is an array of database records, so it's actually made up of a first name, and then it's made up of a last name. I'll just put an F over here, and I'll put an L over here, and then it's made up of an ID. And then, however many you dimension this to, you might have dimensioned it to 100. So it's 0, 1, 2, 3, etc. Okay? So the way that this is supposed to work, you may recall that the first person that we were going to insert was going to be Gabe Ninda, and Gabe's ID number was 90124. Now, part of what should go on here in the constructor is this variable here that I've called nextDBRec. That should have a 0 in it. And when I come over here and I want to insert this into the database, I come over here and I use this to reference where to put the record in. So that means I'm going to come over here and I'm going to put Gabe in here. And then I'm going to put 90124. And what I need to do now is I need to change this 0 to a 1. So I come over here and I erase that. And now I have to figure out how to get back my pen. And I come over here and I put a 1 there. Okay, so you may recall that the second insertion over here was Anton Limbo. And Anton has an ID of 8122, like that. So I would come over here, and again, I use this number now to reference this big array over here, and it says, oh, it goes over here. So I'm going to come in here, and I'll put Anton in slot number 1. And then what I do is I need to change this 1 to a 2. Okay, and finally, number 3, I need to insert Anna Shapepe, and with an ID number of 85000. So I come over here and I see the 2. So it's telling me that I come over here. A little messy, but I think you all get it. And again, what I need to do now is I need to update this. And now it's 3. Okay, so this is what our database looks like at this point. But you may recall earlier on when I said we're going to introduce some functionality into this database, we should be able to list out the contents of the database sorted by any one of these attributes over here. In other words, I should be able to see all 3 of these records, but listing it by the first name, where the first name would come out alphabetical in ascending or increasing order. If we wanted to, we could have it list out the database by last name in decreasing order and do the same thing on the ID. So the question is how are we going to do that? And the answer is we are going to have indexes. And in fact, what we will have for this particular database is we're going to have 3 different indexes. There's going to be an index for the first name. There's going to be an index for the last name. There's going to be an index for the ID. And the indexes, so I'm going to have something over here. I'll call it F index for the first name. And I'll come over here and I'll have L index for the last name. And I'll have something called I index for the ID. And here's what they would look like. So these are going to be arrays. And what's going to happen over here for the first name index, over here I'm going to have the first names, but these things are going to be in alphabetical order. So I'm going to come over here, and the first name I would have here would be Anna. And notice that Anna is at position number 2 in this array here. And then the next one I'm going to have over here is going to be Anton. And Anton is at position number 1. And then finally I'm going to have Gabe. And Gabe is at position number 0. Okay, so notice now if I wanted to print out this database here, and I wanted to print it out in increasing order of the first names, I would come over here to this F index, and I would look at the first entry, and I would go, oh, that's Anna, and that says number 2. So I would come over here, and I would print this out first, and then I would go to the next one over here, and that's at position number 1. And I would print this out second, and then I would come down here to the last position, and I would print that out third. If I wanted to print this out in first name in descending order, I think you can see what to do. It's pretty simple. I would just start off at the end of this array here. I'd start off here, go to position 0. I'd print that out first. Then I would come over here, and I'd go backwards through this array. I would get this one second, which would be at record number 1 in the data array. And then I would come over here and I would get the second one and print that out. So I would traverse this array this way to print out the information in ascending order, and I would do it this way to do it in descending order. Now we can go ahead and create these indexes over here as well. So let's see, for the last name over here, it looks like the first one would be Limbo. that's at position number 1. And then the second one over here would be Ninda. And that would be at position number 0. And then the third one would be Shepepe. And that would be at position number 2. And if I'm going to come over here and I create an index on the IDs, so on the IDs, let's see, the first entry over here would be 80003, and that's at 1. And then I would have 85 1 2 3, and that would be at position 2. And then I would have 90124, and that's at position number 0. Okay, and again, what I can do here now, if I want to print out my database in indexed by ID number in increasing order, I would just come down here and pull the records out of data in this order, 1, 2, and 0. If I wanted to do it in descending order, I would do it this way. Okay? So what we need to do is we need to go back to our definition of our class database, and we need to add 3 of these guys. Now, we're doing object-oriented programming here, and we don't want to have to reinvent the wheel. So people may be wondering, how do I maintain these indexes? What happens if I come along now and I want to add a new person? If you're careless, you might say, well, I would just add the new person down here at the end, put in the number over here, and then resort the whole thing. But no, that is far too much work. We know that sorting is something that takes order n squared, at least with the sorting algorithms that we've learned. But you may recall in chapter 2 of the book, and this is the whole point of this assignment, we learned about these things called ordered arrays. Ordered arrays. And you may recall that when you have an array that is already ordered or already in order, that if you want to insert a new element into it, you just stick it, what you do is you shift these elements down. You start at the end of the array and shift these elements down until you find the appropriate place to insert it. Okay? That only takes, the time complexity of that would just be order n. It's much faster than just resorting the array. So what I'm going to describe to you in just a minute here now is how can we make these things look like ordered arrays? And the answer is it's very, very simple. You'll be able to just copy the note right out of your notes or out of the book, the code for the ordered array, and that's what these things will be. So let's figure out how we're going to put these indexes together. And as I just indicated to you, they're based upon the ordered array that we learned about in chapter 2. Again, you can review your notes and go into the book. The code is right there, and we're going to borrow from it heavily. So you may recall that what happened in the ordered array, the way that we learned about it, we had an array of integers, and maybe we had some new integer here that we wanted to insert into this array, like that. And basically what we would do is we would start at the tail end of the given array, and we would compare these two. And if this was less than that, we would take this and we would copy it down to here. And then we would go over here and we would go, well, this is still greater than that. So we would copy this down to here. And then we would come over here and we would go, well, this is greater than that. So we would copy this over to here. And then we would go, well, this isn't. So at this point, we might have something that looks like this. there'd be a 3 here. There would be, let's see if we can get this correct now. So there would be a 7 here, there would be a 7 here, there would be an 11, and there would be a 27. And then what we would do is we would actually insert the 5 right over to there, so that when we were all done, we had an array that looked like this. 3, 5, 7, 11, and 27. Notice we haven't sorted the array. What we've done is we've just inserted this into the correct place in the already sorted array, and this has a complexity of just n. We want to do the same thing over here with these indexes. Whoops, that's not the index. Sorry. So what's going to happen, I'll redraw an index. So we have indexes that look like this. And what's going to happen is this is a string and this is an int. Okay, so we might have over here Anna, and then we might have Anton, and then we might have Gabe, and I believe this was a 0, a 2, and a 1. And notice what we're doing is we're keeping it in order by this thing over here. So how can we make these into these ordered arrays like this? Well, the answer is very simple. First, what we need to do is we're going to create what I'm going to call an index record. And an indexed record is just one of these things over here. So we would have something like public class index rec, and this would be composed of private string key and a private int where. Now here's the important thing. There are a lot of details that need to be filled in here, constructors, various methods, but the most important method that you need to put in this thing right here is a public int compare to. Okay, and again, if you've never seen this before, you should go review it in your Java books. If you can't read that, that's COMPARETO. And that's one word, compared to. And it's actually very simple, because what we need to do is we need to be able to compare something that looks like this with something that looks like this. And we can see that the way to compare these two is very simple. We really don't care about the number over here. What we care about are just these two attributes right here. So over here, we're just doing a simple string comparison, okay? And that's what's going to help us keep these things in order. So if we have our public class index rec and we have this thing compare to defined, then finally the last step of this whole thing is just to define an index. Well, public class index is it's first of all this is the key right here. It's made up of an array of index records. But then what is all of the code that goes in here? Well, all of the code that goes in here, this is almost identical to the ordered array. Of chapter 2. So the question is what's different from what's in chapter 2? Well, in chapter 2, you may recall that they had an array of integer. And what we've done is we've changed the array of integer to an array of index record. Okay? The other thing that's going to change is that when you go back and look at the code for the ordered array in chapter 2, there's going to be all sorts of things in there where they are comparing elements of the array, and they might be using a less than, or they might be using a less than or equal to. And this would go, for example, when they're inserting new elements into the array, you remember you had to keep moving these things down. Okay, and it was based upon something being less than something else. Well, what you would have to change in the code in here is instead of using this less than, you would have to use an expression that's using compared to. And other than that, the code for this is going to be exactly the same. We're ready to put everything together now. We have everything that we need, so we're just going to review exactly what you need to do. So firstly, what you want to do is you want to define your public class database record. And remember, that was an object that had 3 pieces to it, and they were all strings. We had a place for the first name, we had a place for the last name, then we had a place for the ID number. Okay, all of these were strings. The next thing we wanted to do is we wanted to define public class index record. So I'm going to put over here, by the way, that this is a string, this is a string, this is a string. We wanted to define an index record, and an index record had 2 pieces to it. The first part was a string, and the second part was an int. Okay, and remember what would go in here is as if we were creating an index record on, say, the first name. We would have the first name over here, and this would be where in the database array that it occurred. We wanted to find public class index. Index is nothing more than an array of index records. So I'm just going to say over here, array of index records. But it turns out that this index is nothing more than the ordered array that we studied in chapter 2. So all you need to do is take the code that we have in chapter 2 for the ordered array, and you just need to change a couple of things. For one thing, the ordered array in chapter 2 was an array of integer. We need to change that to an array of index records, which are these objects right over here. And then we just need to look at all of the lines of code that compared array elements. And remember, when you're comparing array elements and their integers, we're going to see symbols like that, or we'll see symbols like that, or symbols like that. And what we need to do is change all of these to some compare to statement. And I am assuming that you all have seen the compare to statement before. If not, you should go back and look in your Java books. This is a fairly standard thing to define when one is defining their own classes. Finally, what we do is we put this stuff all together, and we are going to define a public class database. Okay? And a public class database, first of all, it's made up of an array of database records, and we're going to call that data. So data is an array of database records. We have an integer that's telling us where to store the next database record. Now remember, we just store new records in this array sequentially. So next database record would be initialized to 0 in the constructor, and every time we add a new record, we would add it to the place in data that next database record is referencing, and then we would increment this by 1. Similarly, a database is going to be composed of 3 different indexes. So we have private index, there's a first name index, there is a last name index, and then there is an ID index. I leave it over here for you to think if there are any other variables that should be defined in this class and other methods. Of course, there should be other methods. There are many, many methods that are going to be defined in here. And I urge you all to look at the driver program that is provided for you, and that is what you should use. Okay, that's it for assignment number 1.